Hello there, my name's Desmond Aubrey from Rarefied Technologies, Southeast Asia, or for short, RareTechSEA. And this is just an introductory video about what it is that we do and who I am. By way of background, I've been a thermal engineer, or mainly thermal engineer, for nearly 40 years. I've travelled all over the globe as a technology consultant. I started off my training in South Africa with a Bachelor of Science in Engineering Mechanical, the subdivision mechanical, where we specialised in understanding things like thermodynamics, all the basic engineering stuff, or for physics based, so we have a pretty good understanding of how things work. And then from that I got into heat transfer. Actually, we were the first course that actually started with heat transfer, and I loved it because I'm very passionate about it, because it's very difficult for many people to understand these different things that are going on each side of a plate or a tube, and you've got different coefficients, heat transfer coefficients, and things occurring, different fluid properties and all that. And when I started, a lot of it was quite tough. We had to look up in books and so on. And I went and I actually remember when some of the first decent computer programs were coming out. I tried various of them, and some of them were just, to be honest, rubbish really. And then moved on to a pretty good package, which I actually still use. Actually, it's been prettied up over the years. It used to be called AAA Therm, and eventually it ended up with Chem Stations and part of the ChemCAD suite, CCCAD. It's actually very good for certain exchanges. I then went on to designing my own bitumen units that we used using hot oil, thermal oil, to actually heat up bitumen. And I designed some very novel units in South Africa, which were modular units, actually, multi-modular. And so we could actually heat up bitumen very quickly. Bitumen is very difficult to heat up. So typically what happens, I'll give you an example. There was a particular operation, and they were actually making a malthoid, which was actually let's call it a cloth impregnated with hot bitumen. And they would start up their factory. They'd have to heat it up the whole weekend to be ready for Monday morning. And then it would basically be cold. The plant would be cold by midday, and they'd have to shut down. They couldn't get production. It was just a mess. So I looked at the whole thing and I said, well, I think I can do it differently. And I then looked at an external pump around circuit and worked with the engineer there to develop that. He did that end of it. I did the exchanger side of it. And putting bitumen on the shell side, actually, which was a very interesting way to do it. And it worked exceptionally well. It was a full modular. What used to happen is they'd come in on 7:30 or 7 o'clock on a Monday morning, turn the stuff on, they're ready for production, get going. And it would just keep running. So it basically pushed their production through the roof. So that's basically a pump around type system. It's completely, because bitumen is really tricky. It goes from a very, very viscous down to a viscosity less than water. Later on it's hot, it's quite amazing. And then the other systems I designed were inline bitumen heaters, which would take in the bitumen coming out of the storage through pump, and then basically heat it in one whack and take it straight into the process. And this shocked people because we were getting, the performance was really good, and this was novel. But modular, meaning you could actually add extra modules and clip them together, and I got very long thermal length out of it. It was quite a bit tricky. And then from there I've moved on over the years to all kinds of things. I eventually went into the automotive industry, involved in radiators, condensers, evaporators. That took me through brazing processes. I had to actually develop a new process, or let's call it commercialize a new aluminium process we called composite deposition technology, or CD technology, which was a novel process. What it was is that you had an aluminium eutectic alloy, which was coated in a special process with flux. So we didn't have to add flux, actually spray it like they normally do with lock-a-lock. So we ended up with a much better product, and we could actually braze. We didn't have to use clad materials, so we could actually use heat some very, let's call it very corrosion-resistant fin stocks, which had a certain amount of zinc in them, and we could actually braze that onto bare tubes, for instance, which was quite a trick. Okay, you still can't do that today. Generally, in aluminium, they use knock-a-lock, which I know very well, but they've got to have a clad tube typically. And then they put your fin on top of that, unclad fin. You don't do a clad fin because when you clad it, the cladding starts to flow into the microfins. They've got microfins on these louvers. If you look at your car or your condenser in your car, they're very, very compact. and to get the heat transfer right. So I had to learn all about the heat transfer of that. I even got involved in the CFD side of it, computational fluid dynamics, and got involved in all of that. And I've then moved on to a variety of different processes over the years. And eventually I was brought in by a Swedish company to come and be their consulting engineer to the boss, actually, to the president of Outokumpu Copperstrip AB. That was the Swedish part of it, based out of Västerås in Sweden. And I would fly in and out. I did that for about 5 years, actually. Traveled all over the world with these people. And eventually they had a process that they called Cooper Braze. And they'd been dabbling for about 8.5 years, and the head office was about to shut it down. And they brought me in for 3 months to see if we could turn it around. And I turned it around and got it very successful. Commercialized it and gave them some hope. And they focused mainly on automotive heaters, radiators, and so on. But fashion-wise, was against them. Aluminium kind of still kept going. We pushed them back a bit on the big trucks and certainly the things like trains and so on, where aluminium certainly is just not going to do it. And off-highway as well. Copper is actually very good. But then copper's price went through the roof. It messed everything around it. Okay, but that was a very good process. I actually, in later years, I went on to develop a brazing technology which actually allows you to actually braze a copper. There's these special needle-resistant fins to copper tubes. There was a crowd in South Africa that was making these multi-port tubes in a special process, and they were showing off how good they were. So I actually brazed it with a friend of mine who actually brazed these things, and it was the first time. And if you saw what a primitive condition we used to braze them, it was scary, but we actually got it right. Actually, and they worked nicely. So that was they couldn't get to full production, so that was the one. And then I consulted a lot in heat transfer. I helped folks with these extended fin units, where sometimes they call it air blast. They use block fin. They use different types of fins. Extended surface onto tubes. You might use steam for heating, and you're then heating air, for instance, or you're using air to cool something. And then so I sorted out the software they were trying to use. It wasn't doing the job. I fixed that all up and got that going. And we used that to do a lot of very successful designs. One of the designs I did was for your landfill gas coolers. It was totally novel. What was happening is they put in these energy recovery systems. They would take gas, which is a mixture of methane and carbon dioxide, and they would take it from the dump. It would come out as gas, and then they would pass that through eventually compressors and then onto the motors. And what would happen is the motors would get fouled up, because now you've got this really dirty gas and full of water vapor and so on. And they had to literally change spark plugs probably every second day, or every day actually. And they were really in trouble. So they wanted to cool this down and get a lot of the water out. So I designed a system to go in there. It was the first in the world. But the trouble was that we had to go onto the low pressure side of the compressors, and I only had 50 pascals to work with. It was like nothing. All right. And so we designed this thing, and it was pretty successful. There were a few little glitches here and there, in the sense that it was very compact. The in and out plenums that we used there were too compact, and I was afraid of that. We didn't have any space. And I remember saying to the manufacturer, I said, I think we might have to do a bit of remedial work later, let's see. And so when we ran the thing through, we used chilled water going through it. We were getting a bit of coring. What coring means is that you actually don't get your air onto the full face of the object, and you don't really get all the heat transfer that you think you're going to get from a design, theoretical design. In practice, it doesn't always do that, because it cores and it doesn't quite get there. So I developed ways to actually do a better job and to spread better. So I learned quite a bit. We all learn as you go along through life. But a lot of successful projects there. Also, one of the things that I really enjoyed was a modular system. I got onto this when I was a young engineer. I had been, come out of university, and I went through construction industry, and then went into a big chemical manufacturing outfit. And then they wanted me to go and work in an explosives plant, and I didn't fancy getting blown up. So I then went to a small company that made these modular units. And this was technology that had been developed by a Swiss German called Gesalter. And he was down in Panama. I think he ultimately ended up living in Panama, and he was making units for the sugar industry. And these were made out of essentially pipe components, put together, but very trick. And the ends were all seals, and so you could strip it down, elastomeric seals. And I loved them because you could actually do all kinds of tricks with them. Different types of designs, and you could, if you had a system, for instance, and you wanted to double production, you just slapped another bank in parallel. You clipped it all up, and it was like a Meccano set. It was really lovely, and I've actually got all of that technology available actually for sale. And so that's that. And so it went under a brand name called Transon for a while in South Africa, and they tried it internationally, but it didn't seem to kind of take off. But what happened is I was consulting to a company, and then eventually they wanted to sell this division. They'd acquired this Transon division, which I'd actually, as I say, worked as a young engineer. So I basically helped them for a while, and eventually said, no, I think you need to close it down because your production people really are not up to scratch, and you're wasting their money and time. And so I bought it for the princely sum of R1. But I made the mistake. I went into partnership with two folk who were supposed friends and builders, and they did me in financially while my wife's mom had died, and I had to deal with that. So they stole a lot of money from me. But I ended up with all the technology because I was the technology director, and I had everything. So I've got all of that available. And so I've made some of that available on the market. In fact, by the way, for that I wrote all the software in the original years of how that stuff actually works. So without that software, nobody can design much. But they really are very, very nice systems. So I also got into things like designing heat pumps, very compact heat pumps, which I'm a inventor really in many ways. So it designs compact heat pumps for South Africa, 1 kilowatt up to 4 kilowatt deliveries. Really kind of call it a trickle heat pump, like a trickle charger for electricity, trickle heat pump. And this was really very interesting, but it arrived at kind of a bad time in South Africa. We sold that whole batch off, but and they were very good actually, very, very professional. And the guy that built for me in Thailand, and he did a super job. But, eventually COVID came around, and it kind of put paid to a lot of these things, made things very difficult. What else? So it's the heat pumps, it's all the exchanges. I then got into plate exchanges, because for me, plate exchanger technology was always hidden, and I wanted to know what it was all about, okay? But the Swedes kept it secret. And so what I did is I met up with a guy online who was a chap who'd actually worked for Alfa Laval in the early days, and he handled all the computerization of their stuff. In those days it was all in Fortran and so on. And then he left, and he took a team with him and started SWEP. SWEP was the brazed version, because he liked braze, and he felt that Alfa Laval weren't going to do braze. They do braze now, but they didn't at the time. And then he started SWEP. And then they transfer all the technology with them. They actually they developed, they took a lot of know-how with them into SWEP, and the guy that did all the programming for them was very skillful. And then they formed a little business where they then kind of moved that technology all around the world, and that formed the basis for all the big names out there. And maybe they won't want to admit it, but many of them, the Kelvians, the Gears, all of these guys started off with that technology base, the engine, the actual engine of the software that does the crunching. SWEP does it. They all have it, actually. It goes all the way through to Danfoss eventually. Okay, I think. So they've all got it. And then what happened is we struck up a relationship, and he owed me a bit of money as well. And so I eventually acquired the rights to the source code and started to develop on my own and pick it all up. But he's passed away since. He was a difficult character, to say the least. But he owed that to me, so I've got all the source code, and he knew all about that before he died. That was for sure, and I made sure that he understood all of that. So we ended up acquiring that legally, and I've used it since. But it's actually really nice. And then we've got a module in there which takes the geometry, plate geometry, and predicts the thermofluid performance, as in the heat transfer and the pressure drop. Now, all of this is secret. You won't get this in any books. There's a book that came out with Sundin and a few guys that wrote it. Nice book, expensive too. I think it's about $350, and I bought it. But they don't get it right because they don't know it. They actually don't know that technology. It's kept secret. So I have that, and so I've got software which I call RT Calc, and this version that's now out, Light Designer, and it's got a number of plates in there, and I'll continue adding plates to it. I'm also planning to do an academic version, which I'm just about finished with, to sell to the universities, to start to get them to learn how to work with plate heat exchangers.